So kind of going back, to the procedure we talked about that made up that table, we can now do example 8 here in a very similar way. The sine of 7 pi over 6. Now, it's in lowest terms, so I know it's related to pi over 6, which is a 30-degree angle. I know the sine of 30 degrees is 1/2 because its reference angle is 30 degrees. Now, 7 pi over 6, I got to think, well, what quadrant is that in? 7 pi over 6 is going to be in the third quadrant. And I know that because if I count by pi over 6's, I'm at 0 pi over 6. If I go all the way to pi, that's 6 pi over 6. I'm not quite where I need to be yet. So if I move another pi over 6, that puts me in quadrant 3. In quadrant 3, signs are negative. So this has to be a negative answer. For part B, 10 pi over 3. Now, 10 pi over 3 is more than 2 pi. 6 pi over 3 would be 2 pi. So I have to be aware of that fact, that 10 pi over 3, is more than what that table in the previous slide would show us. But if I still use the same general guidelines, 10 pi over 3 is in lowest terms. And with it having a denominator of 3 in radians means it's related to pi over 3. It has the same reference angle as pi over 3, which is a 60-degree angle. And for a 60-degree angle, the tangent of a 60-degree angle is square root 3. Now I gotta think, where is 10 pi over 3 going to place me? Well, it's going to place me into, I'm going to do a full circle, and I'm going to do 4 pi over 3 more. And the reason why I could do that is to say, well, this is 0 pi over 3. Let me get a pen going here. If I start here, I'm at 0 pi over 3. If I get this to right. Over here, I'd be at 3 pi over 3 if I did a full pi. If I go back to a full circle, I'm at 6 pi over 3. Still not enough. I move all the way over here again to the same position. I'd be at 9 pi over 3. Which means that from 9 pi over 3, I'm going 1 more pi over 3 into this quadrant, which is why I know I end up right there. So I'm just counting. I'm counting by pi over 3's. Recognizing what, I'm not necessarily counting every single pi over 3. I'm counting by multiples of pi over 3, but I have to know how my fractions work. And if you don't understand how fractions work, you're going to have trouble with this. How do I know 6 pi over 3? That's 2 pi. 9 pi over 3 is 3 pi, So I know these in terms of over 3, so I can keep track of where I am. And 10 pi over 3 will put me in the third quadrant where tangents are positive. So no need to change the sign here. 5 pi is an angle that's going to be on one of my axes. So you got to see what it's related to. This would be related to the angle pi. The reference angle is 0, but it's actually more related to 180-degree angles. It's coterminal with it. And so since 5 pi is coterminal with pi, I expect the cosine of 5 pi to be the same as the cosine of pi, which is -1. Now comes D. D is a tricky one. Because a lot of people, when they look at that problem, they'll say, okay, that has a reference angle of pi over 6. It's related to 30-degree angles. So they start thinking, well, tangent of a 30-degree angle is going to be 1 over the square root of 3. So this is going to be it's going to be either positive or -1 over the square root of 3. And they have some of the idea right, but remember, I mentioned this a couple times now, and I'm going to stress it here, that these rules that we're using for our special angles, when I see these denominators of 3, 4s, and 6s, or 2s, only work right if you have it in lowest terms. 10 pi over 6 is not in lowest terms. That fraction can be, for lack of a better word, reduced. The correct term is simplified, but reduced. I can reduce that into -5 pi over 3. Now that's in lowest terms. So that tells me that the reference angle is pi over 3 or 60 degrees. And because of that, the tangent is going to be square root 3, at least at face value. I don't know if that's going to be a positive or a negative yet. I got to figure out where negative 5 pi over 3 is going to put me. And where it puts me, if I'm going in the clockwise direction, because this would be, again, this would be a 0 pi over 3. If I head in this direction here, this would be a negative 3 pi over 3. And if I keep going in this direction, if I go all the way to this axis again, that would be at negative 6 pi over 3. I'm not going quite that far. I'm stopping a pi over 3 short of that. That lets me know that I am going to be in the first quadrant. And in the first quadrant, tangents, like everything else, are positive. So if you know, all suckers take calculus, you know the general values for your reference angles, because anything in that between 0 and 90 degrees is anything in quadrant 1 is considered to be the reference angle quadrant. Um, as long as you know the trig function values for the reference angles, you can figure out any other angle that's related to them.